right? So if you talk about IPv6 addressing, the very first thing that you must aware is conversion, that how to convert binary to hexadecimal and back from hexadecimal to binary, and of course decimals. So this is very primary requirement to understand in IPv6 addressing, that like how to convert binary to hexadecimal, and of course from hexadecimal to binary. So here I'm not going to teach you all those things, because what I think that you already understand. So if you talk about IPv6 addressing, you must remember that it is 128 bits long address. Previously you were having only 32 bits long address, right? But right now you are having 128 bits long addresses. That is why if you calculate total number of IPv6 addresses available over here, then calculation will be 2 raised to the power 128. I don't remember that what will be your exact value of 2 raised to the power 128. But what I know about it, that you can allocate this IPv6 address to all, I mean like to each and everything on this earth, on this planet, right? That much number of IPv6 addresses are available, right? So the next thing is, it will always be represented, in hexadecimal. Till now you were representing your IP address in format of decimal, I mean in decimal number system, right? But here in IPv6 addressing, of course you will configure, you will allocate, or you can say that you will always represent your addresses in the format of hexadecimal. You will never use decimal number system over here in IPv6, right? And it has 8 blocks. I will not say octet, because octet means it will be having only 8 bits, but here you are not having only 8 bits in a single block, right? That's why I will not call it octet, I will simply call it block. So it has 8 blocks, and each block will be having 16 bits. Each block will be having 16 bits. And you must remember that in hexadecimal number system we are having numbers from 0 to right. Total number of characters are 16. So with the combination of all these characters, the number system will be hexadecimal, right? Now the highest number of hexadecimal is what? F. And if you convert it back to decimal is 15. If you convert it into the binary, it will be represented by 4 bits. So because the highest value of hexadecimal will be represented by 4 bits into the binary, that is why there is a rule now that to represent any character of hexadecimal in binary, it will use 4 bits. Or in other words, you can say that we will always use 4 bits. We will always use 4 bits to represent your one character of hexadecimal. So remember that each character of hexadecimal will be represented by 4 bits into binary. Whether it is 0, so if it is 0 in hexadecimal, let's say this is 0. In binary, you will type it in this way, 4 zeros. If it is 1 in hexadecimal, I'll type it into binary, right guys? So represent each character of hexadecimal will be represented by 4 bits into binary. Done? Fine. After it, as I wanted to tell you that how to, or how does it look like actually, right? So we can write IPv6 address in this way, as all of you know very well, that 0 1 A2, then it will be separated by colon. You can also type it 001, then colon 100B, colon C001, colon B D F E C A B C D, colon 100D, colon A002, in this way. So there will be 8 blocks, right? So in this way you will represent your IPv6 address. So you can see that each block is containing only 4 characters, and of course each block will be containing only and only 4 characters. Fine. Now in IPv6 addressing, first 3 blocks would be used to represent your global prefix. First 3 blocks will be used to represent your global prefix. The next block will be responsible to represent your subnet ID. And last 4 blocks will be used to represent your interface ID. Right? I will let you know that what is the uses of interface ID over here. But these things, global prefix and subnet ID, of course, it will be used whenever I will specify your IPv6 addresses. But the thing is, this is all about theory concepts. This is all about theoretical concepts, right? Technically, I mean, technically there will be uses of interface ID only. There will not be any uses of subnet ID, as well as, of course, I will not be using this global prefix as well. I mean, however, I have to specify entire IPv6 address whenever I will allocate an IPv6 address to any interface of the device. But the thing is, they will not be, you will never be able to see that, okay, this is global prefix and this is what, subnet ID. But yeah, definitely I will show you interface ID. I'll show you that, right? But remember that first 3 blocks will always be known as global prefix. Next block will be known as, will be used to specify your subnet ID, and last 4 blocks will be used to specify your interface ID. Understood? Good. Then, as you can look at this IPv6 address, it is looking so long. It's looking very hard to remember. It's looking very hard to remember it. And of course, it is not so easy to remember it. It's not easy. But apart from it, you can also write this IPv6 address in this way. It is not always mandatory to use 1AB. You can also have like 000 colon 000 colon 000 colon 000 colon 000, and once more and once more 00A, or let's say 00F. This is also IPv6 address, is not it? And if you are having this type of IPv6 address, then you can write it in this way as well: 1A2 dual colon F. Because in hexadecimal, if you are having some zeros in the left of any character, then it will not be having any significance. It is something like this. This is what? 100, and this is what? So in same manner in hexadecimal as well, if there are some zeros in the left of the value, of course it will not be having any significance. But it is always understood that, okay, if we are having 3 characters, it means leftmost character will be 0. If here we are having only 1 character, it means in the left of this character all other characters will be 0. It will always be understood. And this dual colon specifies that all remaining blocks are having zeros. All remaining blocks are having zeros. So how many blocks are there? 2, 1 and 2. So how many remaining blocks are there? 6. So all those remaining 6 blocks will be having zeros only. Fine. Tell me, Riju, is there any problem? Sure. So in this way you can short your IPv6 address, right? Now in case in place of this 0, let's say this one, yes, here you are having 1, then you can write it in this way: 1A2 dual colon 1 dual colon F. No, that's incorrect. You cannot short your IPv6 address twice. I mean, you cannot have 2 dual colons, or you can say more than 1 dual colon in a single IPv6 address. It's not possible, because if you are having more than 1 dual colon in your address, how will it be possible for you guys to specify which dual colon is having how many blocks?
Yeah.
Is not it? So that's not possible. That is why it is completely incorrect. So you can write your this IPv6 address in this way: 1 dual colon 1 colon 0 colon 0 colon 0 colon F, in this way. So it is also understood that in the left of this 0 is, I mean, all remaining characters are also zeros. Or you can say 1A2 colon 0 colon 0 colon 1 dual colon F. Both of them are correct. Fine. Both of them are correct. So then after, see, as I said here, I mean, I have already taught you all these things, that it is a 128 bits long address. It will be represented in hexadecimal. It has 8 blocks. Each block will be 16 bits, or you can say that each block will be having 4 characters only. Is not it? 4 characters. Fine. Now if we talk about IPv6 addresses, we are having two types of IPv6 address only. One and second one is what? Multicast. Under unicast further we are having multiple types of IPv6 address, just like unique local addresses. In short you can call it ULA. Global unicast addresses. You can also call it aggregatable prefix. Finally, link local address. However, you are also having like anycast address as well, but here I will not discuss anything related to anycast addresses, right? So here we will be discussing about unique local addresses, global unicast addresses, and link local addresses only, right? And then multicast is always multicast address. Under multicast, we do not have any other type of specification. So if we talk about multicast addresses, they will always start FF00:/8. Multicast IPv6 addresses will always start from FF00:8. Unique local addresses are also known as private addresses. I mean, they are same as private addresses in IPv4 format. Like you were having private addressing in IPv4. In same manner, in IPv6 you are having unique local addresses. In short, you can call them ULA. And it will always start, I mean, these addresses will always start from FC00:7. Global unicast addresses means they are same as public addresses, public IPv6 addresses, and these addresses will always start from, see, global unicast addresses will always start from 2000:3, whereas link local addresses are always known as link local addresses, and they will always start from FE80:10. I'll teach you that what is the meaning by slash values over here, /7, /3, /10, /8. But remember that here in IPv6 we do not have any class like class, full class, less class, A class, B class, C, nothing like that. There is no default subnet mask for anything. Here subnet mask will not be represented in format in decimal format. It will always be represented in the format of prefix length. Here you will be using only and only prefix length. Understood or not? So in IPv6 you will be using prefix length like /20, /25, /26, /27, 28, whatever it is, right? Now multicast addresses, you know very well that when will we use these multicast addresses, because some of the routing protocols, some of the protocols uses multicast addresses to transport their messages, their payload, you understand? Like EIGRP uses 224, I mean in case of IPv4 it was using 224.0.0.10. So in IPv6 as well it will be using a multicast IPv6 address. In same manner, OSPF will also use multicast IPv6 address. So over there I will be using multicast IP addresses, IPv6 addresses, right, for all those protocols. And then after, like you can also implement multicast routing in IPv6 based network. In IPv6 based network you can also enable multicast routing. I'll teach you where can we implement this multicast routing, how can we implement it, and what is the uses of it. I mean all these things we will be discussing during multicasting only. So for multicasting we are having this range FF00:8. So in multicasting, I mean during multicasting only I will be using IPv6 addresses from this range. But these are, I mean here this unique local address ULA is same as private address. Global unicast addresses are same as exactly public IPv6 address. If you talk about link local address, it's quite different. And remember that we people will never use link local addresses to transport data from one broadcast domain to another broadcast domain. Even routers will never populate link local addresses in their routing tables. Remember, you will never find link local addresses in the routing table of the devices. Now you can ask me that, then what is the uses of link local address? See, as per its name, link local address means that their uses would be only on a local link, only in a single broadcast domain. Like within a single broadcast domain, you can use link local addresses. Even I will let you know all these things in more details, but for now, just try to remember that link local addresses means that you can use these addresses while you are transmitting data on a single link, on a common link, right? I mean to say within a single broadcast domain. Unique local addresses are private, global unicast, public. Link local, you can use them only on a local link. So if you want to transmit your data out from your link, out from your own broadcast domain, then you cannot use link local addresses, right? However, I will be giving you the reason. So that why are we having these link local addresses actually. So I'll be discussing it with you, don't worry about that. So first of all, let me tell you the meaning by FC00:7, right? So if you are having, like if you are saying that okay, private addresses are from FC00:7, this dual colon means all remaining blocks are having zeros. This /7 means for 7 bits are reserved. 7 bits are, you cannot modify for 7 bits. You cannot use first 7 bits. So if you convert this F into binary, so it will be 1 1 1 1. C will be 11 12 12. So 1 1 0 0. 0 will be 0 0 0. Again 0 0 0. Colon zeros. Colon zeros. Colon zeros. Colon zeros. You understand? Fine. So now here /7 means first 7 bits are reserved up to here, but at least you can modify this 8th bit, and in place of 0 you can make it 1, and all remaining bits can also be modified, but first 7 bits cannot be modified. So in case if you modify this 8th bit, in place of 0 you are putting it 1, so you will see that sometimes your unique local address will start from FC, and sometimes it can also start from, there is no other value from where your unique local address can start. Unique local addresses will start either from FC or FD. Because first 7 bits are reserved, only first 7 bits. 8th is not reserved, so you can change 8th bit. So in place of 0 you can make it 1. So if you make it 1, then it will come D. I got my point. But you cannot modify first 7 bits. That is why it will be always either FC or FD. Apart from that, all other characters can be anything from hexadecimal number system. So remember that unique local addresses will always start from FC or FD. In same manner, if you talk about global unicast addresses, or you can also call them aggregatable address. So if you talk about aggregatable address, they will be like 2000:3. So if it is 2000:3, which means you can again convert it back into binary. So it will be 0010 000 0000 then 0000 colon Fine. Now in it, because first 3 bits are reserved in it, because first 3 bits are reserved. So you cannot modify these 3 bits only. Of course you cannot modify them, but you can modify this 4th bit. In place of 0 you can make it 1, and if you are making it 1, it means your aggregatable addresses, or you can say global unicast addresses, can start from 3 as well. So remember that your global unicast addresses or aggregatable addresses will always start from either 2 or 3. So if your IPv6 address is starting from either 2 or 3, which means it is a global unicast address, or you can call it aggregatable address. Understood? So this is the meaning of this /3. In same manner, you are having multicast address, which is ff00 dual colon /8, which means first 8. It means it will always start from ff only, and then after you can have any character, any value. You understand? But it will always start from ff. Fine. Okay. Then after it, if we talk about link local addresses, which start from fe80 dual colon /10, you can convert it back into binary. If you convert it back into binary, then f means E means 8 0 10, means that first 10 bits will be reserved. 4 4 8 plus 2 10 up to here. These bits will be reserved, but you see, you can modify these 2 bits as well as all these remaining bits as well. Hey, you cannot modify first 10 bits, that is the minibar /10. You cannot modify first 3 bits, that is the minibar /3. You cannot modify first 7 bits, that is the minibar /7. But then after you can modify any other, right? But if you change like these, values of these 2 bits only, so you know it will be something like this. It can be fe, of course it will start from fe8. It can also start from fe9. Then after it can, next character can be anything. Hello. 4th character can be anything. I'm just trying to say you that if your address is starting either from fe8, fe9, fea, feb, that's it. Means that it will be a link local address. So remember, link local addresses can start either from fe8, fe9, fea, and finally feb. So your link local addresses can also start from feb. Fine. If there are some changes in first 3 characters, like in place of fe8 you are using something else, you are not using any one out from these 4 values, then you cannot allocate that IPv6 address to your interface as a link local address. For link local address it is mandatory, because these are reserved, these are already reserved. These whole addresses are reserved as per INA. INA has already reserved all these IPv6 addresses accordingly, as I explained to you. Like here you can see that this unique local, this is link local address, and link local addresses can start from either fe8, fe9, fea, or feb. Because see, This is already FE8, right? This was already FE8. Then in place of this 0 you could make it 1. Then you can have 1 0 as well.
1 1.
Then 1 1 also. See, so this is already 8, 9 A, and finally B. Tell me if there is any problem, please let me know. Sure. In IPv4 we were having 127 range for loopback addresses. Over here we will be calling it dual colon 1. This is not slash, this is dual colon 1 only. So this dual colon 1 will be used as a loopback address in IPv6. It means that you can communicate with your interface even without allocating an IP address, but with using its loopback address, which is by default what? Dual colon 1. Fine. Okay. Let's talk about link local address. The very first thing that you must remember from link local address, you will never required to allocate link local addresses to an interface of the device manually. However, you can allocate it. You are free to allocate it, but by default you will not required to allocate a link local address to your interfaces. Your devices will automatically create these link local addresses for themselves. Like if there is R1, this is FA0 by 0. If you are going to enable IPv6 address on to this interface of this router, it will automatically create a link local address of it. However, you can also configure this link local address to this interface statically as well. But devices will by default devices will create it automatically. In one case only you will require to allocate link local address manually to your interface when you will whenever you will want to change your link local address. If you do not want to change your link local address, then of course leave it in its default state. Interface will automatically create its link local address dynamically. Fine. As I said that with using link local address, for an example, see, just try it once. And now this is switch, there are multiple hosts, and if all of them are in same VLAN, then you can use link local addresses to transmit data between them. But in case if there is R1, there is R2, behind R2 you are having again some lane users. So from the lane users of R1 you want to transmit data towards the lane users of R2, then you cannot use link local address, because this time you have to across your broadcast domain. So whenever you will require to across your on broadcast domain, then you cannot use link local addresses to transmit your data as destination address, right? And of course as source address as well. So in that case you will require to have either unique local address, which is kind of private address, or global unicast addresses, which are also something like public addresses, public IPv6 addresses, right? So I hope that you people have understood all these things till now. Sardeep, are you okay with it? Link local addresses, if you wanna communicate with another device on a same link, then you will be using link local address. But if you are transmitting your data out from your link, then definitely you have to use either unique local address or global unicast addresses. Second thing, as I said that you will never require to create You will never require to allocate link local address to your devices manually. They will create it dynamically. So now I will teach you that how will it be possible for devices to create their link local addresses automatically, or we can say dynamically, right? So I'm just going to demonstrate that thing to you. So let's say this is this is router 1 and this is FA0 by 0. You are going to enable, let's say that you have said IPv6 enable. Once you will enable IPv6 onto this interface, it will create its link local address automatically. Now we know very well that link local address will always start from FE80 dual colon /10. This is, in this way your link local address will be, of course link local address will be something like this, right? First 10 bits are reserved, and then after, of course, you can have any number. Fine, I know that it will always start from FE80, but what about remaining bits? We are having information about first 10 bits only, then after we are having all zeros, right? So how can we create how can we configure this link local address, or how will it be possible for devices to configure their link local address automatically, or you can say dynamically? So for doing that, of course, it will be using the MAC address of the interface, right, to create its link local address. Just give me 1 second, please. Hello. Fine. So I was saying that, let's say that this is router 1 and it is having one interface which is FA0 by 0. So now, as you know that, of course, it will be having its MAC address as well. So let's say its MAC address is C21A.100B001F. This is the MAC address of this interface, right? And you know that in IPv6 addresses there is a interface ID, and last 64 bits represents interface ID. Last 64 bits inside IPv6 address, as I told you, last 4 blocks were used to represent your interface ID. So last 4 blocks means 64 bits. Fine. So basically your link local address will always start from FE80 dual colon, and then it will specify its interface ID. Now interface ID is a 64 bits long ID, whereas the MAC address, actually it will calculate its interface ID with the help of this MAC address. Problem is, now MAC address is just 48 bits long. MAC address is a 48 bits long address, whereas interface ID is 64 bits long ID. So how can we create this interface ID, like with using 64 bits from 48 bits only? So of course there are 16 bits 16 bits are short. To fulfill this requirement, we will be using here EUI, equipment unique identifier, which is known as FFFE, and this is fixed value, and it will put this EUI just in the middle of the MAC address, just in the middle of the MAC address, right? So this is your EUI, equipment unique identifier, which is fixed FFFE. So it will add this FFFE in the middle of the MAC address, so it will become now FE80 dual colon, and it will be C21A colon, because here in MAC address it was separated by dot, but in IPv6 addressing it would be separated from colon. So 10FF colon FE0B colon 001F. This is your link local address, but still inside interface ID it will change its 7th bit. 7th bit will get changed from the interface ID itself. So if you convert your interface ID back into binary, like you will convert C into binary, then 2 into binary. So finally you see, if you convert, because 7th bit, it means if you convert C and 2 only, then 7th bit will come out, right? Because C will be, tell me, C will be 12 1100, 2 will be 0010, and 1 will be 0 0 0 1. A will be 10 1 0 1 0. Seventh bit, most significant seventh bit, most significant seventh bit from interface ID will get changed. So if it is 1, because seventh bit is this, right? This is 1, make it 0. So finally it will become now FE80 dual colon C0 1A colon 10FF colon FE0B. You understand? FE0B colon 1F. Zero zero 1F.
Zero in that place, it will become 1, right?
Of course, and if it is 1, then it will make it 0. If it is 0, it will come up with 1. Only seventh bit. Actually, if you read MAC address in more depth, in MAC address there are something like GL, UL bits, and this is that bit actually. It is, I mean to say that it is something like that, right? So I don't remember exactly, but it is something like that. You can read this MAC address and then definitely you will come to know that this is the reason, so that we are converting it from 0 to 1 and 1 to 0. So even here it's not that we are simply changing it. We are having reason behind it, that why are we changing it from 0 to 1 or from 1 to 0. So we are having all these things over here. So I hope that you people have understood that how will it be possible for device to create its link local address automatically. Now you can ask me that, sir, if routers are connected with serial interface, then what will happen? Because they do not have the MAC addresses. So if you talk about the serial interfaces, they will be using the MAC address of the first Ethernet port. For calculating this link local address for serial interfaces, to calculate link local address for serial interfaces, it will be using the MAC address of first Ethernet port itself. Like if you are having Ethernet 0, Ethernet 1, then of course it will use the MAC address of Ethernet 0 to calculate link local address of all serial interfaces. What does it mean? That multiple interfaces can have common link local address. Common link local address which means, let's say this is R1 connected with R2, connected with R3, connected with R4. Let's say this is S0 by 0, S0 by 1, S0 by 2. All of them will be having common link local address. This serial 0 by 0, this 0 by 1 and 0 by 2. But still there will not be any problem. You know why? Because link local addresses will never get installed in the routing table of the devices, and also whenever you will transmit your data out from your own broadcast domain, you will never use link local address. And each interface of router belongs to a different broadcast domain. So if your interfaces, if your devices are in different broadcast domains, in that case they can have common link local addresses. There will not be any problem. Is not it? So this time device, of course routers, you must understand it that routers have all interfaces in separate broadcast domain.
So what if our router doesn't have Ethernet port?
It is not possible. And if it is not having that, then of course it always have a pool of MAC addresses, right? It will pick MAC address from that pool. Understood or not? Tell me that how will it be possible for devices to calculate its link local address. Now In IPv6 you must understand that we are having some features over here like no ARP, even no need of DSCP as well, and still you can allocate IP addresses to your devices automatically. Only on one device can configure it manually, statically, and then in that broadcast domain, within that lane, you can allocate IPv6 address onto all other devices automatically, dynamically. It does not support fragmentation. No fragmentation on transit devices. Only source can perform fragmentation. Fine. Now my question is very simple, related to ARP only. Let's say this is router 1, this is R2, this is FA0 by 0, this is FA0 by 0. Fine. Let's say its IP address is FC00:1:1:1/48, and here it is :2/48. Now if you want to communicate from R1 to R2, because you changed just layer 3 technology, not layer 2. Layer 2 is still same. So still your packet will be encapsulated by Ethernet, and Ethernet will require to have source and destination MAC address. So without ARP, how will it be possible for R1 to get the MAC address of R2? You do not have any ARP request over here. You do not have any ARP reply over here. And if you do not get the MAC address of R2 of next hop, till that for Ethernet it will not be possible to perform encapsulation. And if Ethernet do not perform encapsulation, of course your encapsulation will get failed and your packet will be dropped. And I hope that you remember that I performed that practically in IPv4, that we were not getting ARP reply. So if we were not getting ARP reply, it means we were not having the destination MAC address available in our ARP table, and at that moment router was dropping your packets due to encapsulation failed. Tell me. So still you will require to get the MAC address of next hop. So for doing that, to achieve that, actually it will be using ND, which is known as neighbor discovery. Neighbor discovery. So this ND is a protocol, actually that's why we can also call it NDP, neighbor discovery protocol. Neighbor discovery protocol. Fine. And remember that if we are saying that your device supports IPv6, it must support ICMP-v6. And here in IPv6, ICMP-v6 plays a vital role. It is playing a vital role in IPv6. So if you are saying that your device is supporting IPv6 but it does not support ICMP-v6, it means it does not support IPv6 itself. It is mandatory for all devices to support ICMP-v6, and this ICMP-v6 is same as ICMP-v4, but here we are having some other types of messages as well inside ICMP-v6. So basically in IPv6 everything will be based on ICMP-v6, everything. And inside ICMP-v6 again we are having some types of messages such as echo request, echo reply, and some other types of packets too. I'll be discussing all those types of packets with you, which are used by ND within ICMP-v6. Don't worry about that. So basically with using ICMP-v6, because see, of course NDP, neighbor discovery protocol, will be in running, and NDP will be using ICMP-v6 to get the MAC address of next hop. So in place of ARP here, for all types of things, for all tasks, we will be using only one protocol, which is what? ICMP v6. Like if you want to get an IPv6 address dynamically from your neighbor, then again you will be using ICMP-v6. If you want to perform path MTU discovery, I mean MTU path MTU discovery, yeah, so again it will be using ICMP-v6. To get the MAC address also it will be using ICMP-v6. So for most of the tasks it will be using ICMP-v6. That's why I said that if your device do not support ICMP-v6, it means it does not support IPv6, because IPv6 can't perform anything without ICMP-v6. Fine, guys. Okay. Apart from that, summarization is there, subnetting is there, everything is there, right? Fine. Now, as I said that it will be required to get the MAC address of neighbor device dynamically, right? Because without getting the MAC address of the next hop, it is not possible for a device to place your data onto physical Ethernet link, onto physical Ethernet port, right? Fine. Then of course it will be using some types of messages over there, right? And of course there is no gracious arc. So how will it be possible to come to know that okay, it is having a unique IPv6 address? For that purpose it will perform that duplicate address detection, and this DAT will also be performed with the help of ICMP-v6, or you can say ND, and ND will finally use ICMP-v6. So everything will be depending on ICMP-v6. See, if you want to perform that duplicate address detection, it will be performed by ICMP-v6. If you want to get an IPv6 dynamically from your neighbor, then again it will be using ICMP-v6. If you want to know that okay, how many routers are there, then for that purpose also it will be using ICMP-v6. So for most of the task, IPv6, not for most of the task, actually you can say that for everything it will be using ICMP-v6. Fine, guys. Okay, now in IPv6 there are, it will be using some types of messages. It will be using some types of messages such as router advertisement. However, these are ICMP types of messages, right? ICMP-v6 types of messages. Router advertisement, router solicitation, neighbor advertisement, neighbor solicitation, redirect. These 5 types of messages are there. Not only these 5 types of messages are available in ICMP-v6, it is having a huge number of messages over there. Huge number of types of messages within ICMP-v6. These are also ICMP-v6 types of messages. Apart from it, it is also having echo request, echo reply, and unreachable, and all those things as well. But if we are saying that okay, we are going to configure IPv6, primarily IPv6 will be using these types of messages of ICMP-v6. So I think this router advertisement, router solicitation is a type of, it's ICMP message type 143 or something like that. Router advertisement is ICMP-v6 type 144, Then I think neighbor solicitation was 145, neighbor advertisement was 146, something like that. Let me show you actually. Say dual colon 1 loopback address, right? Link local address, first 10 bits are reserved. Then after next 54 bits will be 0 and last 64 bits will be used for interface side. This is the default, right? But you can modify it. You can modify these 54 bits as well. Previously these unique local addresses were known as site local address, but now we are calling it as unique local address. Multicast address FF, fine. See, as I said, dual colon 1 loop back, 2 or 3, right? Global unicast address, aggregatable address, FE8 link local address, FEC site local. Previously we were having site local, but nowadays we are having unique local address. This is IPv6 header version, traffic class, flow label, payload length, next header, hop limit, source address and destination address. This is the normal IPv6 header. Then in this header we are also having some extension headers as well. Some extension headers as well. But this is the a major header. If you are not having extension, I mean this is the mandatory header of IPv6. Version will specify that this is IPv6. Traffic class is same as TOS, type of service, and IPv4. Flow label is like just to tell that okay from where it has to, I mean like as you can see here, flow label. Where is that? This is the traffic class and flow label fields are discussed. Okay, they are saying that forget about it. So I hope that see payload length is same as packet length, next header is same as protocol field, hop limit is same as TTR, and then you are having source address and destination address. That's it. This is fixed 40 bytes long header, 40 bytes long header, because IPv6 address is itself how many bytes? 16 bytes are there. 16 bytes are there. 16 plus 16, 32, and remaining 8. 32 plus 4 plus 4, total 40 bytes. So this IPv6 header will be fixed 40 bytes long header. IPv6 functionality. If you are saying that your node supports IPv6, it means it must support ICMPv6, neighbor discovery, stateless auto configuration, anycast IPv6 address, multicast IPv6 address, and MTU path discovery. Then after we can say that okay, this node supports ICMP. This host supports IPv6. And then after you can see that how to enable IPv6 capability on a Cisco router, so IPv6 unicast routing. And on switch the command will be different. SDM prefer something like that. On layer 3 switches by default, of course they will also not support IPv6, so there is a command kind of like SDM prefer command, right? Like, let me show you. It is something like SDM prefer to do prefer, and I don't remember exactly command, but it will start from SDM prefer. You have to change switching database management. You have to change switching database management. Let me show you. Right? SDM prefer dual IPv4 and IPv6. That's it.
Before that, do we need to assign some space
Where?
for IPv6? We need to allocate some space for them to run IPv6 things.
No, nothing. Right? So that's the only thing that you need to change on layer 3 switches. Then you will also require to restart after saving your configuration, restart your switch as well, otherwise it will not support IPv6. After running this command, restart your switch, but before restarting, save your configuration. Then after, it will start to support IPv6. Right? Fine, guys. Then after it, so I was telling you that okay, in this way you can enable IPv6 address, and you see that you can also allocate link local manually, or just enable IPv6 onto your interface. Then also it will create its link local address automatically. I will also let you know that why does it mandatory, or why does it require to create a link local address for each interface of in case of IPv6 addressing, right? Whether it is serial interface or like generally previously during CCNP we learned that it is required to create a link local address just to get the MAC address of neighbor device, right? But what about serial interfaces? On serial interfaces we do not have, we do not require to get the MAC address of the neighbor device. Then why are we having? Even though, what will I do? I will change link local addresses of interfaces. So if we are taking MAC address of the next hop with the help of link local address, then of course we must not be able to communicate with the neighbor device after changing link local address. That's not true. Basically, link local addresses will be used by devices to initiate your IPv6. Because without having an IPv6 address, it is not possible for your device to transmit any type of message. So if we want to transmit any type of message, then of course we must have any address. So after enabling IPv6 onto any interface, of course you will be having at least link local address onto that interface. With using that address, now your device can transmit your data, can initiate your IPv6. Just wait for a moment, I will discuss each and everything. Now do one thing now. So in IPv6 actually, in most of the cases you will be using only these types of messages, and of course these messages are of ICMP v6, right? These are the part of ICMP v6 only. So see, I was showing you all about router advertisement and all these things. Let me show you all these things. See, ICMP v6 is integral to IPv6. ICMP v6 is integral to IPv6. Every node that implements ICMP v6 must fully implement ICMP v6. If it does not implement ICMP v6, IPv6 will be useless. ICMP v6 is a modified version of ICMP for IPv4. Error reporting and many ICMP v6 functions such as MTU path discovery and neighbor discovery utilize ICMP v6. What I said, right? So for all these tasks, you will be using, IPv6 will be using ICMP v6. The ICMP v6 packet follows the IPv6 header or one of the extension headers and is identified by IPv6 next header value of 58 in the immediately preceding header. So as in IPv4 we were having protocol number as 1 for ICMP, but here in IPv6 header you will be having next header value of 58, which means that it has to hand over it to the ICMP v6. This is kind of protocol number. Fine. Then neighbor discovery. See, as you know very well that for neighbor discovery we are having NDP neighbor discovery protocol. Addresses many problems related to nodes on a single link. It provides the functionality for serverless automatic configuration. As I said, that with using NDP you can also get IPv6 address from your neighbor dynamically without doing any configuration of server. That is called serverless auto configuration, right? Or it is also known as stateless auto configuration. Router discovery, prefix discovery, address resolution, neighbor unreachability detection, link empty discovery, next hop determination, and duplicate address detection. All these tasks will be done by ND. Once again, I'm repeating my lines. Router, see, it provides functionality for serverless automatic configuration. Router discovery, like of course, on a link we must be knowing that how many routers are there, right? So router discovery, prefix discovery. The meaning by prefix discovery is something like that. Okay, for an example, I am a very new host in my network, so that I have to ask routers that from which prefix I have to allocate IPv6 address to myself, right? Address resolution, like you have to get next hop layer 2 address, because you will be having only and only destination IPv6 address. Neighbor unreachability detection, link empty discovery, next hop determination, and duplicate address detection. All these tasks will be done by ND. With IPv4, a combination of many protocols including DSCP, ICMP, and routing protocol and ARP were required to provide only some of this functionality. So like to allocate an IPv4 address dynamically, it was required to configure DSCP. To get the MAC address of neighbor, it was required to implement ARP, and of course to detect duplicate address also it was also required to implement ARP once again, right? So here for all those tasks we are having only one protocol, which is called ND, neighbor discovery protocol. But remember that ND uses ICMP v6 to perform these tasks. So ND itself will be using ICMP v6 only. See, when a node is initialized, it must know a few things before it begins communicating. Like if we talk about a node, if we are saying that okay, it has started to communicate with the other devices, then it must have all this information. It must know its own address, its own IPv6 address. It must know its own prefix information, so that it can figure out how to send packet to node located in other prefixes. It must know about any router on the link. It needs to know how to determine the next hop in the path to a destination. Now ND defines 5 ICMP v6 packets to provide IPv6 nodes with the information they must and should know before communicating. So these messages are there: router advertisement, neighbor, and neighbor finally redirect. So these 5 types of messages are really important messages for us to understand the functionality of IPv6. router solicitation, remember that it will be multicasted by a node whenever it wants router to send a router advertisement immediately instead of waiting for next scheduled advertisement. See, actually what happens, let's say there is a router already, this is switch, now there is, you have added one another router or another host. Fine, router sends router advertisement periodically in IPv6. I don't remember its periodic timer, but it is not fixed, it increments its periodic timer with time, right, for router advertisement. But the thing is, always remember that routers will always be responsible to generate router advertisement periodically. And if router is advertising its, if router is generating router advertisement periodically, in that router advertisement it will specify its own prefix information, MTU size, you understand, and all these basic thing. Basically router advertisement is that message which is generated by a router to inform host or to give that information to host so that host can configure themselves automatically. Remember, if you are adding a host into the network, it will always require to receive a router advertisement to configure itself. So the thing is, router is sending router advertisement. Forget about router advertisement for now, but just try to remember that routers will always be responsible to generate a router advertisement periodically. Now, a host has been added into your network. Now there are two things: either it must inform routers to send router advertisement immediately, or it has to wait for the scheduled router advertisement, scheduled periodic router advertisement. If this host has to wait for next scheduled router advertisement, periodic router advertisement, it means there will be too much delay. So what happens actually, that whenever a node will come into the network, it will immediately generate a router solicitation message, router solicitation, and it will be multicasted. It will be multicasted, right? Router solicitation will be multicasted with using for all routers multicast address, which is ff02:2, right? So this time this host will generate a router solicitation, and remember that when a router receives a router solicitation, it immediately generates a router advertisement. It will not wait for the expiration of that timer, periodic timer. If a router receives a router solicitation, it has to generate router advertisement immediately. So for that purpose, here we are having router solicitation, right? So now you can also go through it. Like here you can read something related to router solicitation, like multicasted by a node when it wants router to send a router advertisement immediately instead of waiting for the next scheduled advertisement. And initializing node may send the router solicitation so that it can immediately learn about configuration parameters and about the existence of routers on the link. Have you understood it or not? So basically router solicitation will be generated by all devices, whoever will be added into your network, just to have information that how many routers are existing over there, and just to get some configuration parameters from your router. Because whenever a router will receive a router solicitation, it will immediately generate a router advertisement. Have you understood it or not? Fine. Let's talk about router advertisement. It will be sent by router periodically or in the response of solicitation. It will be generated by a router periodically or in the response of solicitation. You see. And router advertise their presence as well as provide information necessary for a node to configure itself. What I said, that router advertisement will be having that information so that a node can configure itself automatically after receiving router advertisement. Because router advertisement will be generated by routers, it means your end host will get gateways information automatically. It's not it. And also that prefix information which is configured on your gateway, and also about its MTU size. What MAC address? Of course it will be having link layer address as well. Router advertisement, it will also be having MAC address of the router. Neighbor solicitation and neighbor advertisement. Neighbor solicitation and neighbor advertisement is same as ARP request and ARP reply. Like neighbor solicitation is same as ARP request and neighbor advertisement is same as ARP reply. Now you tell me that what was the uses of neighbors, ARP request? Just to send a request towards his neighbor device to give MAC address, right? For that purpose we were having ARP request. So the task which was performed by ARP request, here it will be performed by neighbor solicitation. You see, enable a node to determine the link layer address of a neighbor, or to determine whether the neighbor is still reachable via a cached link layer address. Sometimes what happens, let's say that, okay, actually in IPv6, see, in IPv4, after getting the MAC address of the next hop, it was never checking the reachability with that MAC address, and if it was, there were some, we were having some problems in case of IPv4. They have fixed all those problems in IPv6. Like in IPv6, what will happen? Let's say that you have learned your neighbor's MAC address. You will place that MAC address into your cache memory, but then after, there are some parameters, there are some conditions by which your IPv6 will also verify the reachability with neighbor. That is the neighbor's next hop address reachable with this MAC address or not? Is next hop reachable with this MAC address or not? For doing that, again it will be using neighbor solicitation. So here you can see that in neighbor solicitation, it is used to enable a node to determine the link layer address of a neighbor, or to determine whether the neighbor is still reachable via a cached link layer address, means MAC address. Cached link layer address means what? MAC address, right? And also enables a node to determine whether a duplicate IP address exists on the link. So to identify that whether duplicate IP address is present onto the link or not, to identify that, it will generate neighbor solicitation. Have you understood it or not? So neighbor solicitation message will be used to perform three different tasks. First, to get the MAC address of neighbor device. Second, just to verify the reachability of the neighbor with cached MAC address, cached MAC address. Because once you have learned the MAC address of your neighbor device, then you must also be able to verify that whether this neighbor device is reachable with this MAC address or not, right? If you are transmitting your data continuously, then definitely there will not be any requirement to confirm the reachability with using that cached MAC address. But if you have stopped to transmit data, then after some time you again try to transmit data towards your neighbor, might be that neighbor have changed its MAC address. So how will you come to know about that information, right? So for doing that, or to achieve that task, actually over here you are having this neighbor solicitation. And finally, this neighbor solicitation will also be used to perform that. And what is the meaning by that? Duplicate address detection. So I hope that you have learned the uses of neighbor solicitation over here. Finally, there is neighbor advertisement. As I said, that neighbor advertisement is same as ARP reply. And what is the meaning by ARP reply? Means you are getting the MAC address of the neighbor, right? Of the neighbor device, right? So in same manner here, you will be using, this IPv6 will be using, this ND will be using this neighbor advertisement. So you can see that here, what is the meaning? What is the uses of neighbor advertisement? Sent in the response of neighbor solicitation, right? Sent in the response to neighbor solicitation. So if neighbor is asking about my MAC address, then definitely I will provide my link layer address information. Link layer address information is MAC address, right? So whenever I will get neighbor solicitation, whenever a IPv6 router will receive a neighbor solicitation, it has to provide neighbor advertisement, and in that neighbor advertisement, it will always specify its own link layer address, which is MAC address, right? So basically, neighbor advertisement is same as ARP response. One more thing, if you talk about neighbor advertisement, of course, it will always be generated by a device in the response of neighbor solicitation. But sometimes your device can also generate neighbor advertisement unsolicited. Sometimes your device can also generate unsolicited neighbor advertisement. You know why and in which conditions? Let's say for an example, you are on a device and you have changed the MAC address of any interface. So out from that interface, your device will immediately send this neighbor advertisement just to inform all others to update their cache memory, that I have changed my MAC address. So for that purpose here, you are having unsolicited neighbor advertisement. See, what is the meaning by solicited and unsolicited? See, if I'm saying that, okay, go and read this chapter, this is what solicited. If you are reading your chapters by yourself, this is what unsolicited means, without, I mean, like if you are doing work without poking you, then it is what unsolicited. And if you are doing work after poking you, then definitely it is what solicited. So if neighbor is, I mean, if device is generating neighbor advertisement after receiving neighbor solicitation message, it means it is solicited, right? And if your device is generating neighbor advertisement without receiving any neighbor solicitation message, it means it will be known as unsolicited. Have you understood it or not? So in same manner, router advertisement would be solicited or unsolicited. Like if router advertisement is generated in the response of router solicitation, it means it is solicited router advertisement. And if it is advertising it periodically, it means it is unsolicited. Understood or not? Fine. Redirect is very, I mean, like, this is really good message actually in IPv6. As you can see, sent by router to redirect traffic to a better first hop on the network. You know, one another feature also exists in IPv6. Like, what happens in IPv6? On a single interface, you can allocate IPv6 address from different prefixes. It means on a single interface, you can run multiple lane environment. Something like this. This is router. There is a switch. You can run one prefix over here, you can run one prefix here, and over this interface, FA0 by 0 on a single interface, you can allocate IPv6 address from both prefixes, from both subnets. So whenever traffic will go from this host to this host, because they are on different prefixes, so they will forward this traffic back to, I mean, to gateway first, and this gateway will send this traffic back towards this PC now, right? If this is happening, it means the utilization of this interface will be too high. So in that case, this router will generate redirect message. This router will send a redirect message to the sender that, see, do not send this traffic towards me. You are having destination host on your own lane. You can directly reach your destination. So for that purpose, we are having this redirect message. Have you understood it or not? See, first of all, packets will get exchanged via via gateway. But this time gateway will send a redirect message back to the sender that, okay, this is, I'm not a best path actually. No need to traverse me. No need to send traffic towards me, because you are having destination onto your own subnet. You can directly transmit data from this host to that host. Have you understood it or not?
Yes.
And this in a redirect message, actually it will provide the MAC address of that host to this source, as well as this router will also send a redirect message to destination as well, that, okay, this is the MAC address of that. So that now they can directly, they are having each other's MAC address. Are you getting my point or not? So for that purpose here in IPv6, we are having redirect message. Fine. Then in more details, see, neighbor router solicitation is ICMP-v6 type of 133. Sorry, it was not 143, it was 133. And router solicitation is type of 133, and this type is inside ICMP-v6 itself, right? Like in ICMP, previously we were having ICMP type 0, type 8. Do you remember? ICMP echo request was type 8, reply was type 1 or type 0, something like that. Is not it? So in same manner here, in ICMP-v6, router solicitation message will be of type 133. Router advertisement will be of type 134. Neighbor solicitation will be type of 135. Neighbor advertisement will be of type 136. Fine. Have you understood it now? Good. You're gonna read some more, all these things in more details. You can go through this document. Router advertisement. Routers advertise their presence on the link and provide the information necessary for a node to configure itself. The router advertisement is multicast to the link scope all nodes multicast group. I will let you know that what is your link scope all nodes multicast group. All nodes means FF02 dual colon 1 because 224.0.0.1 for all, 224.0.0.2 for all routers only. In same manner in IPv6 FF02 dual colon 1 is for all nodes. FF02 dual colon 2 is for all routers only. FF02. See, hello, like EICRP was using FF02 dual colon A, RIP uses FF02 dual colon 9. In same manner for all nodes FF02 dual colon 1, for routers only FF02 dual colon 2. So basically in two different conditions there will be two different types of destination addresses inside your router advertisement. Router advertisement will be having two types of destination address. One is this multicast, if it is sending it periodically, because if it is generating it periodically it means it has to give it to everyone. It has to give it to everyone. But if it is giving router advertisement in the response of solicitation will come from a particular node. So in that case this router advertisement will be unicasted, will be forwarded towards that host only from where it received router solicitation. Understood or not? Hello, are you okay with this statement? So there will be two different conditions, two different addresses to send your router advertisement into two different conditions. If it is advertising router advertisement periodically, then destination will be multicast. If it is giving router advertisement in the response of router solicitation, then it will be unicasted. Fine guys, and see here, these messages are secure messages actually, and here they are using kind of TTL security that we used TTL security in BGP, right? Here that TTL security is already configured. What will they do actually? They will configure default TTL value for all types of messages, whether it is router advertisement, router solicitation neighbor advertisement, or redirect. For all types of messages it will configure its TTL as what? 255. So in case if router advertisement is coming after crossing one hop, its TTL will be what? 254. But it is always expected to receive packet with the TTL 255 only. Hello. Whenever a host will receive router advertisement, router solicitation, or neighbor advertisement or neighbor solicitation or redirect message, it must come from a single network, right? So TTL must be what? 255. So by default messages will be generated by devices with the TTL value 255. So that if you are receiving packet with TTL 255 itself, it means it have not traversed any router. It is not coming after crossing any router. You understand? And if messages are coming after crossing one or two or more than that routers, then definitely its TTL value will never be 255. It will be reduced by 1 or 2. It will be depending on that how many routers, of course routers have been crossed by your packet. So by looking at TTL value, it will come to know that okay, whether it is coming from the local device or not. And this security was not available in case of IPv4. I get my point? Hey, there was nothing like this. Let's move ahead now. So router advertisement, all these things are there. These are neighbor states. Once, let's say that you have learned your neighbor's MAC address, you will insert that MAC address into your cache. Is not it? That in cache we are having some states. Like in ARP table also we were having some states, like it was reachable or it was not reachable, something like that, like it is incomplete, right? Do you remember? Incomplete state was also there when you were not getting ARP response in the ARP reply in the response of ARP request, right? So it was incomplete, it was showing you incomplete inside the ARP table. In same manner, once you have learned, or if you have not learned MAC address, then again here we are having some states like incomplete. Let's say you have sent neighbor solicitation, but you didn't get any neighbor advertisement. Same as you have sent ARP request, but you didn't get any ARP reply. Then it will show you incomplete state. And over there also it was showing me incomplete state in IPV4S1. I get my point. Incomplete. You have sent neighbor solicitation, which is same as ARP request, but you have not received neighbor advertisement yet, which means you have not received ARP reply yet. In that case it will show you incomplete state in your neighbor table. Reachable. Let's say that you sent neighbor solicitation, you have also got neighbor advertisement, and you are sending data to that. You are sending data to that MAC address. Its state will be reachable. Let's say you learned your MAC address of neighbor, you transmitted some data, but now you have stopped your data to transmit towards that MAC address, towards that neighbor from last 5 seconds. So if you do not send traffic towards your neighbor for next 5 seconds, then after your state will move from reachable to stale. What does it mean? Oh, it's not 5 seconds, 30 seconds, sorry, 30 seconds. So an entry in the neighbor cache has not been verified as reachable within past 30 seconds. An unsolicited neighbor advertisement message will add an entry to the cache for the sender of the message with state stale. No action is required until traffic is sent to the stale entry. Means that if you do not send any traffic towards your MAC address, towards your neighbor for next 30 seconds, in that case its state will move from reachable to stale, and it will not take any action till until traffic is sent to the stale entry towards that MAC address, right? There will not be any action. It will show you that okay, it is in stale state. Now once your entry has moved into stale state, then after, if you start to send traffic towards that entry, towards that MAC address, then within 5 seconds, or you can say that just after 5 seconds, it will verify reachability as well. See, if you are transmitting data for that MAC address which is in stale state, then after transmitting data, just after 5 seconds, it will verify reachability. It will send once again neighbor solicitation. So after 5 seconds, if it has sent neighbor solicitation and if it does not get reply within 5 seconds, then it will move into delay state. It will move into delay state. And if, see, no reachable verification has been received within past 30 seconds and a packet has been sent to the specified neighbor within the past 5 seconds. If no positive confirmation is received within 5 seconds of entering delay state, okay, send an NS and change state to the probe. Okay, what does it mean actually? Let's say that your MAC address was in stale state. Now you have sent your traffic to that stale entry. Now within 5 seconds it has to verify reachability. It has to verify reachability within 5 seconds. Right? and during those 5 seconds it will be in delay state. It will be in delay state after transmitting your data, right? And just after 5 seconds, see, during those 5 seconds it will be in delay state, but now after 5 seconds it will generate a NS, neighbor solicitation. If it receives neighbor advertisement, it means reachability has been verified. It means reachability has verified, so it will move back into reachable state. But after sending neighbor solicitation, if it does not get neighbor advertisement back, then from delay it will move into probe state. You see, and NS has been sent to verify reachability. No neighbor advertisement has yet been received. Try to understand. If you have, let's say it is happening very first time, you do not have your neighbor's MAC address, you have sent a neighbor solicitation, but you didn't get neighbor advertisement, it will be in incomplete state. Fine. If you have sent neighbor solicitation, you have received neighbor advertisement, it means you have got the MAC address of neighbor, it will be reachable state. Now you were sending traffic, but now you have stopped to send traffic towards that MAC address, and you are not, you have not sent any type of traffic within past 30 seconds. It will move from reachable to stale state. Now it will move from reachable to stale state. Okay, it will remain in stale state, and your device will not take action until you send traffic towards that stale entry, right? Fine. Now your entry was in stale state, but now you decided once again to transmit data towards that MAC entry, right? You will send that traffic towards that stale entry. It will move into delay state. It will move into delay state, and once it has moved into delay state, within 5 seconds it has to verify reachability. If it was not confirmed, reachability was not confirmed within 5 seconds, it will generate neighbor solicitation, and if it does not get neighbor advertisement back, then it will move into probe state. But if it has received neighbor advertisement in the response of neighbor solicitation, it will move into reachable state once again. Have you understood it or not? So these all states are there. These all are neighbor reachability states in IPv6. Have you understood it or not? So remember, router advertisement will never be generated by end host. Router advertisement will be generated by routers only. Router advertisements will be generated by routers only, not by end host like laptops or desktops. Laptop desktops can generate router solicitation, neighbor solicitation, as well as neighbor advertisement. But router advertisement, yes.
No NA has been received.
Neighbor advertisement. NS, neighbor solicitation. Right? So all these things are there. Fine. We have covered that how does it really works. The only thing which is left is practicals of these basic things, right? So now tomorrow we will continue practicals of IPv6. Fine, guys? But try to do one thing, just go through all these rules of IPv6, through all these theoretical concepts of IPv6, because this is really mandatory, guys. These things are really mandatory to understand IPv6, because like if someone asks you that what is the data flow of IPv6, how will you elaborate? Like in IPv4 we were having like, okay, it will send ARP request and it will get the reply, but if you don't know all these concepts of IPv6, how will it be possible to elaborate the traffic flow in case of IPv6? So this is really mandatory to understand that, okay, what happens if a user is going to transmit data very first time in case of IPv6.